How's it going, guys? In this video here we're going to be looking at the internal construction of this machine. It is a Kisae 2000 watt pure sine wave inverter. This is one that I got off of eBay to repair, but I'm unable to repair it. But I thought I would open it up and show you guys what's the inside of it, give you my thoughts on the internal construction of it, and there's some things about it that is good and bad, but just like always, I mean, there's good and bads about everything, but one of the biggest points is the price point. Alright, the owner's manual of this machine. It's kind of tacky. It covers multiple units, basically almost every unit they sell, including modified sine wave and true sine wave. And for the price point of this machine, which is $500 to $530 on eBay, no matter who sells it. On Amazon, $330. So, for that kind of price, you think you'd have a model strictly only owner's manual. Alright, first thing we'll look at is the fans. They seem to be decent quality. I wouldn't say, A grade. Say if you had A, B, and C, I would say they're B. They do have some kind of branding mark with an R. Brushless. They seem to turn freely. I'd say they're decent quality. The receptacle on the front is a standard household GFI. I mean standard household is, you go Lowe's and they sell this exact very outlet. Branded Cooper. Excellent outlet. And given the fact that it does have this GFI outlet, that would mean that the output wires on here are phase correct. Like, this does not have a live neutral, so it's not doing the half voltage thing. And an inverter like this could be, you could backfeed it into your house. You could. It doesn't have the wire up feature, but it could safely do it, assuming that you had your mains disconnected. You could ground it to your house. You could put the neutral to neutral and hot to hot, and there would be no issues with this inverter. Because if it did have a live neutral, you could not hook a GFI up to it. It wouldn't work. On the note of the price point of this machine, this right here is the only branded piece in the machine. This Cooper outlet is the only branded thing in this thing. There is some small caps here that's Nichicon, but all of these large caps right here are no name at all. These FETs, one of the things about repairing this inverter is I cannot locate these FETs. You run the part number across multiple search engines, even go to stores. There's no reference to these FETs. I can't even find the branding of these FETs anywhere online. I cannot find the branding. I even went to a search engine looking for, just going by symbols, the symbols of the manufacturer, and I went through hundreds of pages of branding symbols, and I can't even locate the manufacturer through the symbol on it. So that's not the reason why I can't fix it. I kludged some in here that is generally what you find in one of these machines. It should have worked, at least tried to work with the ones that I stuck in it. Problem is that an oscillator's bad. One of these ICs right here, surface mount, wee little tiny microscopic things with legs, is bad. I checked all the emitter resistors, they're all good. It's an oscillator problem. The solder on the board is definitely California compliant. I mean, I got a 60 watt iron, and I could not get stuff desoldered with it. And that solder iron is a pretty good one. I've taken it, you know, and put it on giant terminals, like, you know, like you got these wires here. And they usually got like massive amount of solder on the other side, and of course you got to heat up, you know, that wire before the solder melts, and that iron usually does the job. I couldn't even get these legs out of this thing. So, you know, if the oscillator worked, if it did, I would have went back, because I got like a couple dozen of these FETs. So I just kludged them to the previous legs and then chopped them back off later. But anyways, I had sure connections. You know, it wouldn't have been good for a load, but enough to see that the thing would work. And if it did, I would have went back through and went through other means of getting these legs out of here, but there's no point in it. So anyways, back to the branding condition. I mean, it's just for the price point of this machine, even at $330, you should have like at least some like IRFs or something in here, you know, something that you're normally gonna find. The fact that they are so generic components that you can't even locate the manufacturer, let alone the part number, that's pretty bad in my eyes. A good point. The construction of this thing is pretty good. Nice, clean. All of it seems to be automated assembly. I mean, I'm not even seeing hand soldered wires. I'm not even seeing that. I mean, it seems the only thing maybe not automated is, you know, the gluing process of some of this stuff. That was another thing too, is the fact that they did glue a lot of stuff. Things that's going to get bounced around and move and vibrate. They did a nice job gluing that stuff. Another thing is awesome about it is it has tons of capacitance. I mean, I don't think for 1500 watt to 2000 watt, you know, where this thing sits, this output right here, capacitance, is awesome. We got four 470 microfarad caps. Despite the fact that they're generic, it's awesome that they're in there. On the input side, you got 3 boost stages with 4 capacitors. That's pretty typical. Sometimes there's 2. It's decent. It's decent. There's nothing wrong with that. But one little complaint I got is the fact that there's only 3 boost stages in here. It's 12 volts. This is a 12 volt to 120 inverter. I have owned 20 some inverters and fixed probably 15, and typically inverters, I would like to see at least 4 of this size in here for 2000 watts at least. If I was to make a guess just by what I'm seeing here, this thing would probably be able to run up to about 1600 to 1700 watts. It probably wouldn't be able to do much more. If it did, say you could load down 2000 watts on it, but it ain't going to output it. You'd have, it might continue to try to, you know, stay running, but you'd be running at like 100 volts or something. It would be sagged so bad that you're not actually getting it out of it. It might, I've seen inverters where they'll just sit there and they'll continue running, but they can't actually do it. So if this was 24 volt with 3 of these in here, I would have made no mention of it, because then your boost stage don't have to do as much because the input. Got a nice toroid here for the sine wave output. Like I said, it's nice design. It's got a coated board. It's coated, so that's awesome. It's not going to corrode. I've often taken apart some of my inverters and actually painted them with clear spray paint, just so that I didn't have a corrosion issue. The lugs on the back are professional looking. They seem to be decent quality. It's not like a gummy plastic, so it probably ain't gonna melt super fast. It may actually be designed to actually handle a little bit of heat. You know, kind of like a plastic spatula. You know, it seems to be that kind of that kind of material. My only complaint with that would be is that I like opposing, like, you know, this lug's here, this lug is over here, you know, more distance apart. Oftentimes when people's hooking stuff like this up, you know, your batteries are always hot, you know, and depending on whether or not you got a switch in between, your cables are hot when you're hooking them up. And this close together, it's pretty easy to have an accident. And also, for the sake of the manufacturer, it's a risk for them having them this close because, you know, short circuits and things like that. I mean, a short circuit, if you shorted the wires together, it's going to be before the internals of this thing, but if something happens to the machines, people oftentimes go back for their warranty. But I like seeing them spread apart, but the quality of the connections I like. Well, just for the sake of people might wonder, I did check the pre-driver transistors that actually drives these FETs. I did check those. They're all good. So how I actually got back to the IC, it just remains to puzzle me. It's very possible that IC went bad, and that's what actually took this boost stage out. Another thing I kind of find is kind of interesting is that instead of doing like a bus system in here where all these boost stages run together off the same fusing and same bus, they're individual. You got 3 30-amp fuses there, 3 30-amp fuses down in there, and 3 over here. So my guess is that this thing actually only runs one of these at a time. Like if you're going to be under, say, 500 watts, it'll just run this one, and then if you go above that, it'll turn this one on, and then you got a second boost stage running, and then, you know, say you get up to 1200 watts, and then this one here will kick in. It's the way it seems to be set up. Each boost stage has its own driver FETs, pre-drivers. So they seem to be all individual, which would help with efficiency. It should be pretty efficient with that kind of a setup, because when it's sitting there doing nothing, there's only one boost stage actually running, whereas a lot of cheaper inverters, the whole boost stage is up and running. So you have a lot of amperage draw doing nothing. It's grounded several spots on this board. You got a ground here, a ground here, ground here, and a ground here, and this one here goes out to the outlet, but this thing is grounded everywhere. It's awesome. It grounds to the case in a lot of places. The cabling, the input cabling, a lot of inverters only have one wire for one boost. This one has 2 and 2. There's 6. You know, 3 different. Each boost stage has 4 wires, 2 positive, 2 negatives. So that's pretty decent there. So my whole thoughts over this thing is I probably wouldn't do 2000 watts. You could probably cruise at 1600. You probably could. Which just seems to be a normal rule of thumb with these inverters across the line, other than like Go Power, Xantrax, and let's see, a Power Braid. Most of you Power Braid, I've seen some kind of, you know, like I like this. This right here is kind of like Power Braid, where it's decent quality, design made, but this right here is a lot like a Power Braid. But you know, like you go get a Go Power or Xantrax, they will do and cruise along at their rated power, what's on the front of the box. For the most part that I've seen, I've never owned them. I just watched, you know, going by basing on what I've seen on other videos, people testing them out. Cheaper inverters generally 80%, and then you got the super cheaps like Power Jack, and I've owned some of those. They're good for 50%, maybe 60% of what it says on the front of the box. So you go and buy a 2000 watt Power Jack, figure that you only get about 1000, maybe 1100 out of it. 1500, I owned a 1500 and it was good for about 850, and that was at its top end. It was only good for about 850 watts. But anyways, that's my thoughts on this machine. I hope anybody that's interested in looking at one watches this video. You know, give you a base upon what you think for price wise. For 300 and 330 bucks from Amazon, I think you could do. That's okay, I guess. That's okay, but definitely not the eBay's 500. No way. But just all in what you think. This is, I haven't really seen a whole lot of failed units on YouTube for this, at least as of yet. I think this is the first video. The one I'm making is one of these tore apart on here, so maybe it's just a fluke that this went. Anyway, I'll catch you guys later.